Passage 7. Enzymes are large protein molecules that increase the rate of chemical reactions in living systems. The substrate is the substance that interacts with the enzyme in a reaction. The acceleration factor is the factor by which the enzyme increases the rate of a reaction. Figures 1 through 3 show the effects that changes in temperature, pH, and substrate concentration have on the red reaction of a substrate when enzymes A and B are present. Figure 4, okay, so let's look at those real quick. Okay, so this first one is as the temperature changes, this is enzyme A, this is enzyme B. This tells us how much the reaction changes. Change in reaction. Okay, this is figure 2 is pH. Same thing, and it tells us here that 7 is neutral. So, and this tells us how much the reaction rate changes. And again, this is A and B, and it's telling us the concentration of the substrate, or what is being put in, what is the substance that's doing the reaction. So, okay. Figure 4 shows the effects that changes in the concentrations of enzymes A and B have on the rates of reaction in substrate solutions of the same concentration. So in this one, they kept the enzyme concentrations the same and varied the substrate. And in this one, they kept the substrate concentration the same and varied the enzyme concentration. Okay, so these are sort of like little opposites. 3 and 4 sort of go together. But then 3 also goes with 1 and 2. All right, let's look at our questions. According to figure 2, all right, here's figure 2. Enzyme A has the fastest rate of reaction at a pH. Enzyme A has the fastest rate of reaction closest to, and there's the fastest rate of reaction, wherever it's highest on the chart, and that's at about 5. A, enzyme A, fastest, pH is 5. So, F, 5. 37, based on the data in figure 2, so we're also in figure 2, at which of the following pHs, if any, do enzymes A and B have the same acceleration factor? Okay, so it's going to be the pH where they cross, right there. And at that pH, they both have the same acceleration factor. So what pH is that? We want to know the pH. So it's about 6.6 at pH 5, at 6 only. No, at 6.7. That's close enough. All right, 38. A scientist claims that the acceleration factor of enzyme B is dependent on both enzyme and substrate concentration. Do the data in figures 3 and 4 support her claim? Okay, so figures 3 and 4, put that there. Here's figure 3. Here's figure 4. Okay. The acceleration factor of B depends on the substrate concentration. So does B change as the substrate concentration change? Yes, it does. Does B here, does the acceleration factor for B change here as the concentration changes? Yes, it does. As a constant. So, yes. So we have no, no, yes, yes. And we say the acceleration factor is dependent on enzyme concentration but not on substrate concentration. That's incorrect because that wouldn't even be a yes. We said it does depend on enzyme, is dependent on both enzyme and substrate concentration. So yes. Because the acceleration factor changed when each of those changed. All right, 39. A scientist claims that for the conditions used to obtain the data for figure 4, the acceleration factor of enzyme B at a given concentration will always be greater than that of enzyme A at the same concentration. Okay, so let's just pick a concentration. 0.5 is a concentration. So which one is bigger? B, which acceleration factor is A, is greater than B. So he says the factor for enzyme B will always be greater than enzyme A, and that's not what we found. We found the opposite. So do the data support his conclusion? No. And now we got to explain why. Enzyme B shows a lower acceleration factor at all enzyme concentrations tested. Enzyme B shows a lower acceleration factor at all substrate concentrations tested. Okay, so we're testing enzyme concentrations, not substrate concentrations. So this one's incorrect. And yes, B was lower for all of them tested. So 39A is correct. 40. Okay, number 40. The figure below shows the relative acceleration factors for pepsin, an enzyme found in the stomach. So this is pepsin. And trypsin, an enzyme found in the small intestine. So this is trypsin. pH is down here. Based on this figure and figure 2, okay, so this is figure 2. One would best conclude that compared to the acidity of solutions in the stomach, okay, so this is just telling me, okay, so it's wanting me to compare acidity for solutions in the stomach and the small intestine. And it says pepsin is found in the stomach and trypsin is found in the small intestine. So compared to the acidity of solutions in the stomach, the solutions in the small intestine are higher pH, and a higher pH means less acidic. So less acidic, G. So this one's sort of interesting. Really, it's only giving you, when it asks you to look at figure 2, it's really just helping you out on remembering what is more pH and less pH. You hardly ever have to actually remember science facts for yourself on the science reasoning test if you'll pay attention to what it tells you to look at. All right, that's it.